Hello everyone. Welcome you all to today's trigonometry class. And today we are going to study a very interesting and a very new topic. So let's enjoy the class. Let's begin it. Okay, so here as you can see the screen, what is written on it? Trigonometry ASTC rule. Okay, so let me just introduce you what we are going to study today. So that so we are going to study first what is ASTC rule. Okay, so and in the screen you can very well see all sine tan cos, right? So it means full form of ASTC is all sine tan cos. Okay, that we are going to study. Next, we are going to study periodicity of trigonometric functions. Then, sign of trigonometric functions in different quadrants. So, we have four quadrants. The coordinate axis divide the plane into four quadrants, four parts. We call each part as quadrant. So, starting from here, you see first quadrant, second quadrant, third quadrant, and fourth quadrant. So, sign of trigo functions in various quadrants, and also tricks to apply the formula. Okay, so the trick, of course, I will be telling you in the last, because I have to explain you the logic first. Okay, so let's begin with ASTC rule. So as I said, here I have written all sine tan cos. Okay, so now all sine tan cos. So it means in first quadrant, all trigo ratios are positive. Okay, first quadrant, all positive. In second quadrant, we have sine. Okay, means this third quadrant, tan positive. Fourth quadrant, cos positive. Okay, so it means sine theta, tan theta, cos theta. Without theta, sine, tan, cos, they have no meaning. Now, whenever I say first quadrant, as you can clearly see here, so we are starting from this. Look at the diagram. So starting at this point. Now from here, whenever you reach here 90 degree, first quadrant. So it means on x-axis you are having 0, for example. Now here you have 90 degree, means pi by 2. So in between, so whenever you have any angle in between, so it means in first quadrant, theta lies between 0 and 90 degree, means 0 and pi by 2. Okay, 180 degree equal to pi radian. We have just studied this. Okay, and second quadrant, you see, after 90 degree you are moving in a circle, right? We are studying circular system of measurement in our syllabus. So when you are moving in this direction, I mean anti-clockwise direction, from 90, when you are reaching here, so let me just take it as A, B, C. So at the moment you reach C, you are covering semicircle, right? It means you are covering here from 0 radian, from 0 degree to 180 degree or pi radian. Okay, now second quadrant is between 90 degree and 180 degree. So here angle line between 90 degree, I mean pi by 2 to pi. Okay, so any angle lying between 90 degree, more than 90 degree, less than 180 degree. For example, if you say 120 degree, so 120 degree will be angle in the second quadrant, right? Now coming to, you are moving in a circle, just to remind you of, we are arriving at D, for example. So here it is 270 degree, third quadrant is over. So now in third quadrant, angle in third quadrant means theta is more than pi and less than 3 pi by 2. Okay, 270 degree means 3 into 90 degree, means 3 pi by 2. and finally you are at fourth quadrant. So it means here theta is more than 3 pi by 2 less than 2 pi. Okay, so you are again at A. So it means you are completing one circle. So completing one circle means completing 2 pi radian, means 360 degree. Okay, then you can move further also. So now let's keep here from 0 to 0 to 360 degree. So let's, for the time being, let's focus on the quadrants. It means first quadrant, that is angle in first quadrant means here angle is more than 0 and less than pi by 2 acute angle. Similarly, second quadrant angle will be more than pi by 2 less than pi. Angle in third quadrant like pi to 3 pi by 2, and in fourth quadrant it will be more than 3 pi by 2 less than 2 pi. Okay, so let's restrict ourselves, I mean within 2 pi radian, right? One rotation. It is for the time being, means for some minutes. Okay, so now whenever angle in this, I mean the measurement of the angle is like this. Now come to the next figure. Yeah. So here you see, whenever you are in first quadrant, see ASTC, here all positive. In first quadrant, all trigo ratios are positive, means theta lies between 0 degree and 90 degree. So sin theta, cos theta, tan theta, all positive. So when sin theta positive, cosec theta will be positive. When cos theta positive, sec theta will be positive. And when tan theta positive, cot theta will also be positive, right? All positive. Now coming to second quadrant. Yeah, second quadrant, here it is written S, means sine. So sin theta positive, cosec theta positive. So it means what? Suppose for example, theta equal to 150 degree. So we have to see 150 degree, it is greater than 90 degree, okay, and less than 180 degree. It means 150 degree is an angle in second quadrant. So whenever we calculate the trigonometric ratios, sin 150 degree will be greater than 0. Okay, cos 150 degree will be less than 0, and when sin cos, these two, I mean one of them is, I mean if they are of opposite sign, right? Sin positive, cos negative, or sin negative, cos positive, then obviously tan will be negative. Okay. And now come to third quadrant. So third quadrant T, AST. So it means tan theta positive, so cot theta is also positive. Okay. Now in fourth quadrant C, ASTC, cosine is positive, so cos theta positive means the reciprocal sec theta will also be positive. So it means if you take 300 degree, for example, 300 degree. So here 300 degree is more than 270 degree, less than 360 degree. So this is an angle in fourth quadrant. So it means cos 300 degree will be greater than 0, whereas sin 300 degree will be less than 0, and obviously tan 300 degree will be less than 0. Okay, so that is basically as per the sign, whenever you, as per the quadrant, whenever you take the trigonometric ratios, so you have to see the angle lies in which quadrant. Depending upon the quadrant, so you can decide whether the trigonometric, that particular trigonometric ratio will be positive or negative. Okay, so as I said, when theta equal to 150 degree, because 150 degree is an angle in second quadrant, and second quadrant here sin theta is positive, right? So sin 150 degree will be positive, and cosine cos 150 will be negative, and obviously tan 150 will be negative. Similarly, whenever you are in third quadrant, for example, you have 200 degree, right? So 200 degree, it is more than 180 and less than 270 degree. So 200 degree is an angle in third quadrant. In third quadrant, tan is positive. So tan 200 will be, tan 200 degree will be positive, whereas sin 200 degree and cos 200 degree will be negative. Is it clear? So as per the quadrant, we will decide whether that particular trigonometric ratio for that angle will be positive or negative. Okay, so this is all about ASTC rule, all sin, tan, cos. Right? Now coming to periodicity of trigo functions. So this is very, very interesting. Okay, now whenever you just moving along a circle, okay, just let me write down here periodicity of trigonometric functions. I'm just writing in short. So periodicity of trigonometric functions. So whenever we say periodicity of the function, periodic function means the repetition in an interval. It means in a regular interval, it is being repeated. For example, if you say, yeah, so let me, yes, as we are moving along the circle, okay, I am taking this one only. Okay, so you have x-axis, y-axis. Your starting point is here, right? And it means it is 0 degree or 0 radian. So let's take in radian measure only. Because we are taking the circle, so in circular system of measurement, unit of measuring the angle is radian. So now your starting point is A. So you are starting from 0 radian. Now when you reach here, it is pi by 2, right? This is pi, so it is A, B, C, then at point A, B, C, D. Okay, now here it is 3 pi by 2. Again you are arriving at this point. This is your 2 pi. Suppose for example, I want to just now reach here again and again. So maybe you can imagine a circular park, right? So you are walking along the park. The park is circular in shape. So at this point P, you want to be here again and again. So it means to be here, what you need to do, you start from A. So this angle, now this angle is theta. Okay, now again to come here again, after completing one complete rotation, means 2 pi radian, again you will be here. So it means first, the starting point it was theta. After one complete rotation, you are again here. So 2 pi plus theta. So do not stop. Again you walk. Now again you are at this point, but this time after 2 complete rotation, means 4 pi plus theta. Again you keep on moving. Again you are at P. So it is 6 pi plus theta. So like this, because to come back to the same point on the circle, you have to complete one rotation. So every time you are there, no, so one complete rotation you have to, cover. So in that way, you can just see you can observe the pattern. Theta 2 pi plus theta, 4 pi plus theta, 6 pi plus theta, like this. It means the pattern here is 2n pi plus theta. So what we can observe here, after every 2 pi interval, the same angle is, same position is repeated. Okay, so sin theta, here you can say sin theta equal to sin 2 pi plus theta, that is equal to sin 4 pi plus theta. Similarly, sin 6 pi plus theta, and so on. Okay, so what we can conclude here, sin theta equal to sin 2n pi plus theta. Okay, n is any integer. So here you can say, it means, so we can say sin function is Yeah, sine function, yeah, sine theta is periodic function of periodic function of 2 pi. So after every 2 pi intervals, sine function is being repeated. Okay. So if you imagine graph of sine function also, that you can also observe. So yeah. So that is it. Similarly, cosine, in case of cosine, the same thing also happens. You can just try. So also you can say cos theta is periodic function of periodic function of 2 pi. Okay, it means you can write mathematically cos 2n pi plus theta equal to cos theta. Okay, so n belongs to set of integers. Okay, so what will happen in case of tan? Okay, now see, as you know, tan theta is positive in first quadrant as well as third quadrant. So in first quadrant, every time you are getting 2n pi plus theta. Now here it is pi. So now you see 0 plus theta, again pi plus theta. Okay, here pi plus theta. Again you come here, 2 pi plus theta in first quadrant. Third quadrant, again you will have what? 3 pi plus theta. Again 5 pi plus theta, like this. So that means if you combine first quadrant and third quadrant, where tan function, tan theta has same sign. So it means here you see tan theta, tan pi plus theta, tan 2 pi plus theta, tan 3 pi plus theta, tan 4 pi plus theta, tan 5 pi plus theta, and so on. So here we can observe the pattern whenever, yeah, so here tan theta is periodic function of pi. So it means tan n pi plus theta equal to tan theta. Okay, so you may have the question, why are we taking only first quadrant? So you can even take the second quadrant, any quadrant you can take. But coming back to the same point again and again, in case of sine and in case of cosine, again you are completing 2 pi radians. So after every 2 pi radians, sine function and cosine functions are being repeated. Okay, similarly, whenever you take tan, like I have taken here first and third quadrant, even if I take second and fourth quadrant, again here tan theta is negative, here also tan theta is negative. So no change, right? So any quadrant you take, the same result will be valid for, any quadrant basically. Okay, so periodic function means whenever any function is repeated after a regular interval of time. After a regular interval, it may be time, it may be angle, right? So that is basically periodic function. So in general, periodic function, maybe you can write like, if you have fx equal to f x plus k, right? So it's like this. Okay, anyway, here we will be considering only, trigo functions. So that is all about periodicity of trigonometric functions. And because of this periodicity, the practical application you can say, see, whenever we are breathing, our breathing also takes a definite pattern. So our breathing cycle is not sometimes, no, it is not 10 seconds and sometimes not 10 minutes. So everybody has once, every one of us, we have our breathing pattern, right? So we breathe in, breathe out in a regular interval of time, right? So yeah, if you say yoga, pranayam, whatever exercises, breathing exercises you are doing, so it follows a definite pattern. So you can just relate these to trigonometric functions also. So in anything, any function, it may be breathing function, it may be trigo function, it may be any other function fx. So if it follows a definite pattern, in regular interval. Okay, so it can be taken as periodic function. Is it clear? Okay, next coming to, yeah, so next one is, let me just, what we have planned to study today. Yeah, so our plan is like we have covered ASTC rule, then we have covered, yeah, periodicity of trigo functions, then next sign of trigo functions in different quadrants. This is one of the very, you can say very important concept in trigonometry, and it is actually the basis of everything. Okay, so now you see various quadrants. When we take various quadrants, so as you can see, trigonometric functions, we are studying the circular system. So circular system means we do not have any particular, format. Format in the sense, it's not between 0 and 90. It's not. So the number of rotations, number of times you cover the circle, so you can have measurement of angles accordingly. So now, as I said, 0, if you start like this, you are covering like this. Okay, first quadrant, second quadrant, third, fourth. So 0, pi by 2. So we know 0 degree, suppose for example, yeah, sine 0 equal to 0, we know. Okay, and basically, yeah, we start with, and also we know sine pi by 2, we know it is 1. Similarly, for cosine, tangent, everything we know between 0 and pi by 2, and also we know sine, cosine, tangent at 0 and also pi by 2. But what about the other quadrants? So here you see in first quadrant, if we go to first quadrant, so we know this thing. Sine first quadrant is between 0 and 90 degree. Okay, so you can have sine pi by 2 minus theta equal to cos theta. Cos pi by 2 minus theta is sin theta. Tan pi by 2 minus theta is cot theta. And we know the reciprocals also. Okay, so one more thing I want to tell you, like, yeah, whenever you go like this, no, angle measured in clockwise direction, so that is basically, it is negative angle. Okay, so sine minus theta equal to minus sine theta. Because if we go like this, I may take in this way, it is, we are in fourth quadrant. Cos minus theta equal to cos theta. Tan minus theta equal to minus tan theta. Okay, so this is another thing. Okay, now you see, if I write here sine, so first quadrant you are familiar with. Okay, we will start with second quadrant. As you know, second quadrant angle is more than pi by 2, less than pi. So it means we can express any angle in second quadrant as pi by 2 plus theta or pi minus theta. Okay, more than pi by 2 means pi by 2 plus theta. Less than pi means pi minus theta. Similarly, angle in third quadrant can be taken as pi plus theta or 3 pi by 2 minus theta. Okay, in fourth quadrant, this can be taken as 3 pi by 2 plus theta or 2 pi minus theta. Again, you go back to first quadrant. So here we are completing 2 pi, so it will be 2 pi plus theta. Okay, now let's take in this way. If I write here sine pi by 2 plus theta, so it means sine, if I write like this, pi by 2 minus of minus theta, so it is sine just like using the first case, sin pi by 2 minus theta is cos theta. Here it is cos minus theta, that is equal to cos theta. Similarly, you can have cos pi by 2 plus theta equal to minus sin theta. So after getting these two, you can get the tan pi by 2 plus theta equal to minus cot theta. Okay, now in third case, if you take sin pi minus theta, so sin pi minus theta, we can write like this, sin pi by 2 plus pi by 2 minus theta. So basically, I am just telling you the explanation in brief. So sin pi by 2 plus theta, using the second block of formula, sin pi by 2 plus theta is cos theta. So here cos pi by 2 minus theta, it means you are getting sin theta. So it means we are getting what? Sin pi minus theta. Sin pi minus theta equal to sin theta. Similarly, you can prove cos pi minus theta is minus cos theta. After getting sine and cosine, you can get tan pi minus theta equal to minus tan theta. Okay, in second quadrant, sine is positive, you are getting positive sign here, and cosine is negative, you are getting negative here. Now second quadrant is over. Coming to third quadrant. So it is, if you write here sine pi plus theta. Okay, let me take for cosine, right? So that, yeah, cos pi plus theta. If I write like this, cos pi minus of minus theta. Okay, cos pi minus theta is minus cos theta. Means here it is minus of cos minus theta. Cos minus theta equal to cos theta. So you are getting minus cos theta. Similarly, you can take this one also. Let me just write it. Sin pi minus of minus theta. Sin pi minus theta is sin theta. So here it is sin minus theta, that is minus sin theta. You see the pattern. So that the tricks can be applied very easily. Now take the ratio tan pi plus theta. So when sine and cosine both are negative, tan will be positive. So you are getting here tan theta. So once you get sine, cosine and tangent, the reciprocals can be obtained easily. Okay, the fifth one is, we are in third quadrant. So 3 pi by 2 minus theta. Now let's see this. So whenever you have sine 3 pi by 2 minus theta, it is pi plus pi by 2 minus theta. Sine. Now sine pi plus theta is minus sine theta. So I can write here minus sine theta. In place of theta, we have pi by 2 minus theta. Sine pi by 2 minus theta is cos theta. So you are getting minus cos theta here. So our conclusion is sin 3 pi by 2 minus theta equal to minus cos theta. Similarly, cos 3 pi by 2 minus theta is, yeah, so it will be minus sin theta. After getting these two, tan 3 pi by 2 minus theta will be cot theta. So now this, from these three, you can say, sets of 5 sets of formulas, what you can conclude here? Yeah, so I can write now, it is, we are in fourth quadrant. For fourth quadrant, so in similar way, you can just try, if it is 3 pi by 2 plus theta, cos 3 pi by 2 plus theta, and tan 3 pi by 2 plus theta. So this is sin 3 pi by 2 plus theta. This is minus cos theta. This is sin theta. And this is minus cot theta. And if I take sin pi minus theta minus sin theta cos 2 pi minus theta, that is cos theta, and tan 2 pi minus theta equal to minus tan theta. So what I am going to tell you here, the trick to remember, the trick to apply the formula. So from these 7 sets of formulas, we could have observed some patterns. So what is my observation from these 7 sets of formulas? Yeah, so this, I can say. So whenever you have, so maybe this will be helpful for solving the questions and applying this. So whenever you have, see, we have two patterns. One is like multiples of pi plus minus theta, right? It means one is n pi plus minus theta. The other one is 2n plus 1 into pi by 2 plus minus theta. So whenever you have n pi plus minus theta, it means whether it is pi plus minus theta, या 2 pi plus minus theta, या 3 pi plus minus theta, या 4 pi plus minus theta. Whenever you have this thing, so what will happen? No change in trigo ratio. No change in trigo ratio. Change in sign, yeah, you can write here plus minus sign as per the quadrant. As per the quadrant. I'll take example. But whenever it is odd multiple of pi by 2 plus minus theta, here change in trigo ratio. Change in trigo ratio. Change in trigo ratio means from sine it will be cosine, from cosine it will be sine, from tan it will be cot, from cosec it will be sec, and similar way. So, and plus minus sign as per the quadrant. Okay, so if you remember this trick, so I don't think you will make any mistake. Okay, so for example, yeah, so here you see whenever you have, I mean whether you write any multiple of pi or even multiple of pi by 2. So whenever you have even multiple of pi by 2, it will be any multiple of pi. Okay, so you may remember in this way also, right? But I think this is very, very convenient. For example, you have sine 10 pi plus theta. Okay, so suppose 10 pi plus pi by 4. Now, so whenever I said 10 pi, I have to have this thing in the mind. You see, whole trigonometry will be only in two axes, you can say. You are starting from here, 0, here it is pi. Okay, now here 2 pi, here it is 3 pi. Okay, so it means this side, I mean right side of, I mean on x-axis to the right of origin, in positive side of x-axis, all the angles are like 0, 2 pi, 4 pi, 6 pi, like this. So even multiples of pi. And whenever the angle is on x-axis but left side of origin, I mean negative side of x-axis here. Okay, pi, 3 pi, like this. So here all odd multiples. Okay, so even multiple of this. So 10 pi will be lying here. Okay, 10 pi plus pi by 4 means it will be, yeah, the angle will be in first quadrant. So this will be equal to, as I said, n pi plus minus theta, no change in trigo ratio. So it means sine will become sine, and yeah, so we have to write sine pi by 4 plus minus as for the quadrant. So 10 pi, the position of 10 pi is where? It is on x-axis, right side of origin. Okay, whenever you go like 10 pi plus theta, you are coming to first quadrant. So first quadrant all positive. So sine pi by 4, this is equal to 1 by root 2. Similarly, if I take another example, suppose I take cos 9 pi plus pi by 3. So 9 pi will be where it is odd multiple of pi. So here you can have, you can say x-axis. Yes, because on x-axis in one side you are having even multiple of pi, the other side you are having odd multiple of pi. So 9 pi plus pi by 4, sorry, pi by 3, 9 pi, the position is here. Okay, if I write here A, this is B. Position of 9 pi will be at B. Now 9 pi plus pi by 3 means you are coming to third quadrant. So in third quadrant, cosine is negative. So no change in trigo ratio means you write cos pi by 3. Change in plus minus sign, yeah, plus minus sign as for the quadrant. It is in third quadrant. So it means third quadrant cosine is negative. Put minus sign here. Cos pi by 3 means cos 60 degree 1 by 2. So you are getting minus 1 by 2. Okay. So any angle of any greater value, you can calculate very, very easily by using this trick. Okay. So I hope the concept is very, very clear to you. So maybe we can wind up the class, and next class we can take some questions based on ASTC rule. Okay, so thank you so much, and I hope this trick and this concepts are quite helpful to you. And once you are thorough with these tricks and concepts, maybe in the next class it will be easier for us to take some questions, and you will feel very comfortable in solving the questions also. Okay, so thank you so much, and if you like the video, don't forget to press the like button. Okay, so let's wind up the class now.